Ever get lost in thought in math class?
Yeah.
Like as a teenager.
Yeah.
I think we all did. Daydreaming about rock star fame or blasting off to space, the usual stuff.
Right.
But the guy we're diving into today, mathematician Ray Solomonoff, well, he was aiming a bit higher than that at 16.
Oh, yeah.
He wanted a method to solve, get this, any scientific problem.
Wow. Now that's ambitious.
Talk about reaching for the stars.
No kidding.
Now, before you start thinking, okay, hit me with that sci-fi music, this isn't some far-fetched fantasy. Solomonoff, he was onto something big, something deeply tied to how AI actually works.
Really?
Yeah, like right now, today.
I'm intrigued. Tell me more.
Let's deep dive into it.
Yeah.
So Solomonoff, he was all about patterns, like truly captivated, believed that if we could just crack the code, find the patterns in all the data out there, we could unlock the universe's secrets.
Okay.
And his secret weapon, well, maybe not so secret.
Hmm.
You might have heard of Occam's razor.
Yeah, the simplest explanation is usually the best, right?
Exactly. But Solomonoff, he wanted to take that simple idea to a whole new level.
Interesting.
Okay, so imagine you're trying to, I don't know, explain the way a baseball flies after you throw it.
Right.
You could go all out, come up with these insanely complex equations to map that whole trajectory.
I see, yeah.
But what's the simplest explanation? Plain and simple.
Hmm.
Good old Newton's laws of motion. Gravity doing its thing.
Elegant, right.
Yeah.
And what's really cool is that physicists, they use this principle all the time, like constantly. Always on the lookout for those simple, elegant formulas to explain everything, from the tiniest atom to like a giant black hole.
So Solomonoff wanted to make a program to basically do that automatically, find
Yeah.
the simplest explanation for anything.
Yeah.
Yeah.
Like that was his big vision. And at the same time, get this, there was this other brilliant mind way over in Soviet Union, actually. Andrei Kolmogorov, also a mathematician, obsessed with probabilities, like random numbers and stuff.
Really? So two guys, same idea, different parts of the world.
Pretty much. But here's the thing about Kolmogorov. He was tackling this huge E question, like how do we even define simple? In a way you can actually measure.
Yeah. Seems kind of subjective, right?
Yeah.
Like what's simple to me might be, I don't know.
Exactly.
Okay, pop quiz time.
Shoot.
What's the simplest explanation for this number? 25,041,903.
Okay.
Just random bunch of digits. Maybe the product of like 3 prime numbers, or here's a curveball. What if it's Kolmogorov's birthday? Just all jumbled up.
Okay. I see what you're saying.
Even with something as, supposedly clear-cut as numbers, simple can get kind of messy.
And that's where Kolmogorov comes in. He had this breakthrough. Came up with this idea. It's called, are you ready for this? Kolmogorov complexity.
Okay, hit me.
Basically, it says the simplest explanation for anything at all, is the shortest computer program you can write that produces it as an output. Shorter the program, the lower the complexity. Makes you think, right?
It's like when you compress a file on your computer, right?
Yeah.
Smaller file size means the original data, it had more patterns in it, more repetition. Like it's less complex in a way.
Exactly.
Who knew file compression could be so deep?
Right.
So, okay, we've got Solomonoff over here dreaming of this ultimate problem solver. And we've got Kolmogorov giving us the tools to actually measure simplicity. This is huge. It's like we're about to crack the code of, well, everything. But
Well, there's always a but, isn't there?
there is, and this is where it gets really interesting. We got to talk about the Berry paradox.
Okay. Berry paradox.
Yeah. Okay, so dictionaries, numbers, Berry paradox.
Yeah.
It all feels connected to this Kolmogorov complexity thing,
Yeah.
but I'm missing a link somewhere.
It's all about limits. Like, we hit a wall with the dictionary, right? We can't describe every number with just those words. We bump into the same wall with Kolmogorov complexity. We can't always find the absolute shortest program for every single output.
Because of the Berry paradox thing.
Exactly. It shows us that that's like mathematically impossible to prove. We've got the shortest program in every case. It's a limitation we got to accept.
So no algorithm to rule them all. No ultimate understanding through pure computation. Our dreams are shattered.
Now, hold on. Don't get too dramatic here. Just because we can't achieve perfection doesn't mean Kolmogorov complexity is useless. It's still a powerful tool. Like, think of it as, like a really good telescope.
Okay.
It might not show us everything in the universe with perfect clarity, but it can still reveal amazing things, hidden structures, patterns we wouldn't see otherwise.
Okay, I'm with you.
And get this. Those compression algorithms we use all the time, they're kind of like Kolmogorov complexity in action. Yeah. By compressing data, we're finding shorter ways to write it right. And that helps us uncover hidden patterns, redundancies. like how we compare DNA sequences or find anomalies in stock prices, even making sure those random number generators are actually random.
Wow, so it's like we started out wanting to solve everything and stumbled onto a way to understand information itself.
Exactly. And this is hugely important for building AI, too. Finding those elegant, efficient programs, that's basically what machine learning is all about.
So it all comes back around,
Yeah,
full circle, back to AI.
totally.
We may not be able to solve every single problem, but we can find those hidden patterns and come up with elegant solutions. I mean, who would have thought a teenager's daydream would lead to all this?
It's pretty mind-blowing when you think about it, that's for sure.
It really is. Well, that about wraps up our deep dive into the fascinating world of Kolmogorov complexity and the quest for the simplest explanation.
And what AI is really all about.
Exactly. But here's a final thought for you. What if you could create a program to find the simplest explanation for anything in your life? That relationship that just ended, a decision you regret making, even like a weird dream you had, what hidden patterns would you uncover? Keep that question with you, and who knows, it might just lead you to your next deep dive.